as we hinted in the previous video, we learned what an inner join is. So let's learn about outer joins also now. And there are three types of outer joins. There is something called as a left outer join, right outer join, and a full outer join. We'll learn each of them with a simple example, right? So imagine I have two tables, T1 and T2, right? Let's just construct an example so that it's easier to understand it with a toy example, right? So let's assume I have columns C1, C2, and C3, right? We'll build this example as we go. Let's assume I have A1, AB, right? 2, CD, right? Okay, let's just skip 3 here, okay? Let's just construct an example which is easier to understand. 4EF, 5GH. Okay, let's assume this is my table 1. Let's also draw table 2, right? So if you look at my table 2, let's assume it has columns C4, C5, and C6, and the elements are 1, 0, 1, right? 2, 1, 0, right? 3, 0, 1. 3 doesn't exist here. That's good for us for our example. 5, 5, 1, 0. Let's take this example, right? So now, if I write my query as follows, if I say select star from table 1, join table 2, right, on, right, T1.C1 equals to T2.C4. Okay, this is your standard simple inner join that we have seen in the previous videos, right? Let's understand what's happening with inner join. What am I saying here? I'm saying that I want to join T1 and T2 wherever T1.C1, which means this column, is same as T2.C4. So what will happen here? Let's write down the resultant, right? So this row 1 is present here. Where else 1 is present here? There is only one place. So we'll get an output. So because we are saying select all the columns, we'll get 1, A, B, okay, 1, 0, 1. So this is column 1, column 2, column 3, column 4, column 5, column 6. This is my output table going to look like. Now let's look at the second row. There is 2 here. Is there 2 somewhere? Yes, 2 is here. So these two will be combined or joined, right? So you get 2 CD 1 0 or 2 1 0, right? Now let's look at 4. Okay, so these two are resolved. Now let's look at 4. Is 4 present anywhere? No. 4 is not present anywhere. So you would not get a row corresponding to 4, right? Because 4 is not present anywhere here, right? So this is also solved. What about 5? Is 5 present here? Yes, 5 is present here, right? So I would get 5 GH, G and H from here. My C4 is again 5. I would get 1 and 0. So this is going to be my resultant table. This is going to be my resultant table if I perform simple inner join, right? One way to understand inner join diagrammatically, right? There's a very nice simple interpretation of inner joins. You create 2 sets. Okay, create 2 sets. This is your simple Venn diagrams, right? This set, this circle represents all the elements in T1.C1. Okay, these elements basically. Okay, this set represents all the elements in T2.C4, right? The 2 columns that we are comparing with the on condition here, right? So if you take the set of all the elements that are present in T1.C1 and all the elements that are present in T2.C4, you create a different set. So the final resultant that you would get, the set of values that you will get here, is the values that you will have in the intersection of these 2. Right? Look at this. What if you take this as one set, right? Write a set 1, 2, 4, 5. This is the set of values. This is your T1.C1 if you write it as a set, right? If you write T2.C4 as a set, what would you get? You would get 1, 2, 3, 5. What is in the intersection of both of them? 1, 2, and 5. because 3 is here but not here, 4 is here but not there, right? And what is the intersection, what is the final resultant table that you got? Look at the C1 values or the C4 values, because they're going to be the same. Okay, you get 1, 2, 5. You don't get 4, you don't get 3. So the rows that you would end up getting corresponding will correspond to the values in C1 and C4 such that they belong to the intersection here. This is very important. This is what your inner join is. So inner join, the resultant table, let's call this table T. The resultant table will contain only those values in the joining columns which are common between both of them. This is your simple inner join, right? Now let's look at a different example. Okay, so this is, I'm drawing an example so that it's easier for you to understand. Okay, I'll just erase this and let's learn a slightly different form of join. This is clear, right? Very simple example. The reason I'm drawing again here, I'm erasing and drawing here, is because I have the tables here, right? I have the tables here. I don't want to just rub off the tables. Now imagine I have a slightly different query. Let's say my query is like this. Select star from T1 join T2, T1 join T2 on, so instead of join, what I want to have here is this. If I say left join, or if I say left outer join, I'll explain you this keyword, what it means. I'll explain you what this left outer means. Okay. Select star from T1, left outer join T2 on T1.C1 is equal to T2.C4. Let's assume this is my SQL query. Now let's break it down. What is the only difference from the previous query? We added this part. So instead of saying a simple join, we added something to it. So this is called a left outer join. What happens in a left outer join is this. Okay, let's write the resultant so that it's easier for you to understand. In a left outer join, first I'll take this. Okay, does this match with something? Yes, it matches with this. So I'll just write 1 A B 1 0 1. This is of course column 1, column 2, column 1, column 2, column 3, column 4, column 5, and column 6. Very simple, right? Because the 1 is present here. So till now it's behaving exactly like your inner join. Now let's look at 2. For 2, here again you have 2. So we get 2 CD 2 1 0. Very simple. Now let's look at 4 here. This is the interesting part, right? In the inner join case, 4 didn't join with anything because there is no value here. So we simply dumped it. We did not have a row in the resultant table with 4. But since we are saying left outer join, because this is the left side of the join. See, we have 2 tables here, right? We have T1 and T2. T1 is on the left side of T2 in the join operation, right? So we take this 4, E4, but nothing corresponding to 4 is here. Okay, there is no 4 here, 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 here. So we would just write null, null, null. What about 5? Yes, for 5 there is a corresponding row here. So we would say 5 G H 5 1 0. So if you look at the difference between inner join and left outer join, in the left outer join we took the left side of the table. Okay, we went through each of the rows. If the row has a corresponding matching row based on this condition, if it has a matching row, we are combining it. If it does not have a matching row like this row, if it does not have a matching row, we are just filling null values. So from the set diagram that we saw earlier, right? If this is the set of all of my T1.C1 and if this is the values of T2.C4, in the left outer join, I am going to get the keys that I'm going to get here are going to be all the values that are present in C1, right? All the values that are present in C1, whether they're intersecting with C4 or not, doesn't matter. Wherever they don't intersect, right? This region does not intersect with T2.C4, like this row. But we still fill it in and we'll just fill null values here, right? Very simple. So we have the keyword left outer here. So whether you write this as left outer or just right left, It doesn't matter because there is no concept of left inner join, right? So you can write this as left outer join or just left join. If you just write it as left join, it automatically understands that it's a left outer join, right? Very simple concept, right? Basically what you're doing here is for each row here, you have a corresponding row here. If there is a matching row in T2, you would combine it. If there is no matching row, you would just fill null values. That's what is your left outer join or your left join, right? Again, very simple. Now let's look at the right outer join. Very similar concept, but let's go through it so that it's clear for you. I'll just erase this example again, right? So that we can use the same tables here. Okay, let's write the query now. Okay, the query will look like this. Select star from T1, right outer join T2 on T1.C1 equals to T2.C4. Now when we say right outer join, we could have also said right join. This is same as saying right join. The keyword outer is optional here, right? Because there is no concept of right inner join. There are only right outer joins. Now what happens here? Let's write it down, right? So first you go here, right? 1AB, there is a matching one. So you start writing it. 1AB, sorry, let me just give some space here. Okay, 1AB, 101. Now let's go to 2, right? 2CD, 210. 4. There is nothing corresponding, so you leave it. Okay? Because the right outer join gives importance to the right side table, not the left side table. We'll understand what I mean by giving importance. Just give it a second. Now let's go to the 5th row here. There is a corresponding 5th row here. So you would enter 5GH510. Are there any rows left here? This row has been taken care of. This row also has been taken care of. This row also has been taken care of. The only row that is left is this. So we would also fill this row in, right? Under column C4, C5, C6. So we'll say 0, 3, 0, 1. But rest of them will just fill null, null, null. Because for the 301 row here, there is no corresponding row here. Because 3 does not exist anywhere here. That's why the column C1, C2, C3 will become null. But 301 exists under C4, C5, C6. So in the case of left outer join, even if you had a row without a matching on the left table, so this is your left table, this is your right table, right? This is on the left side of the join operation, this is on the right side of the join operation, right? In the case of left outer join, whenever we included 4EF null, null, null. Okay, so left outer join basically says that even the rows which don't have matching rows in the right side table, just fill them with null values corresponding to the columns in the right side table. In the right outer join, we exactly do the opposite. We keep 301, we keep the 301 here, right? But on the left side, there are no corresponding values here. So we would say null, null, null. But we would not respect this 4EF because 4EF is on the left side. We are not doing a left outer join, we are doing a right outer join. In a right outer join, if you look at these two sets of T1.C1 and T2.C4, this is what will happen. All the rows, all the values that are corresponding to this column will be present in the final table. Look at this, all the columns are present. So all the values are present. None of them are missing. But something from T1.C1 like 4 could be missing here. So this is called a right outer join. Okay. Obviously, you have seen left outer join, you have seen right outer join. Is there an outer join that takes care of both? Obvious question, right? So let's look it up. Okay, so I'll just erase this again. I'll erase it carefully so that we don't erase the actual data itself, right? So we have seen a left outer join and we have seen a right outer join. We have seen what the inner join is, what the right join is. What about full outer join? Very simple. select star from T1 join T2. Sorry, I shouldn't say join here. Full outer join. Full outer join T2 on T1.C1 equals to T2.C4. Here, instead of saying full outer join, I could have said full join also. Now, what is the resultant here? That's important. Let's write down the resultant. So you get 1AB, 101, right? Because they're matching. Again, you get 2CD, 210, matching. For 4, what happens? There is nothing corresponding. So what do you write? You say 4EF. I'll write null as capital N, just in the interest of space. But N here basically means null. Okay. Then you say, what about 5? 5, there is something corresponding. 5GH, 510. What about 3? Null, 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 301. So in the full outer join, okay, look at this row. This row doesn't have a corresponding row here, but you still fill it in and you leave nulls. This row here does not have a corresponding row in this. That's okay. You just fill in the details and leave null, null, null. So what's happening from the Venn diagram that we have seen is all the values that are present in T1.C1 and T2.C4, all of them are going to be present in the resultant table. Right? This is very important. So one other important detail that I wanted to tell you, right? So initially, if you remember, we wrote select star from T1, join T2 on T1.C1 equals to T2.C4. This was what we wrote earlier, right? Here, instead of just writing join, I can also write it as inner join. So if you write it as inner space join, so if you write it as inner space join, this is same as just writing join. Inner is an optional keyword, just like outer is an optional keyword. Right? I just wanted to call this out so that whenever you see this keyword inner, you're not confused. Okay, you can write it as inner join or just join. It will just perform simple join, simple inner join. That's what I mean, right? So we have seen an inner join, a left outer join, a right outer join, and a full outer join, right? Now let's actually see some examples here, right? So imagine so let's look at this query, right? So here again, I'm printing movie.name and movie.genre from movies M, left join, which means if there is a movie without any genres, still print it. Just print null values here. Okay, on this thing limit 20. So let's see what happens here, right? So let's actually execute this. Okay, see, you get some null values here. So you have a movie here which doesn't have any genre, so you see a null value here. Similarly, you have a movie here without any genre filled in, so you see a null value, right? Straightforward, simple stuff. Okay, so the next immediate question is, are there more complex forms of, okay, you'll have null for missing counterpart rows. We've already discussed this. Straightforward. You can either use left join or left outer join, right join or right outer join, full join or full outer join, join or inner join. There is something called as a three-way join, which is an interesting thing. See, we have done two-way joins, right? You have table 1 and table 2, right? Let's look at an interesting example here. Suppose I have 3 tables. I have actors A, roles R, and movies M. There are 3 tables here. Okay, so first I'm joining these two using this condition. On the resultant, I'm again joining with movies. Okay, on the resultant that I get, I'm again joining. So first this join happens, then these two will get joined. The resultant that you get from here will be joined with this. That's called a three-way join. You can also have a k-way join where you're joining more than 3 or 4 or k tables, right? Again, this condition is slightly tricky, but it's easy to follow. Let's walk through this example, right? You have actors A, which is joined with roles R, based on this condition, you get a table. Let's call the table T. Now you combine or join this table T with movies M. Okay, based on this condition. So this is a big condition with a logical AND. See, your condition, your joining condition, the ON, can have a complex Boolean expression like this with a logical operator in between. That's perfectly okay. And from the whole thing, you want to get the first name and the last name from the actors table. We are using aliases here. Roles are actors A, movies M. Right? One thing you should keep, a practical note about joins is one of the most time-taking operations in most database jobs are joins. Joins can become very, very computationally expensive because look at it. You have to combine data in two tables, right? Of course, there are techniques in databases which database admins know very well or database designers know very well called indexing, right? That we discuss, that we typically learn in a database course at an undergraduate level, right? So indexing is a whole topic in database design which helps you make your joins more computationally feasible. Right? They make your joins faster in a nutshell. But still, joins can be very, very expensive. There are tons of ways on improving. It's a whole research area on how to improve the performance of joins. Okay. One of the biggest or the most computationally expensive jobs in the whole of traditional databases or relational databases or table-based databases that we typically discussed, the relational databases, right? One of the most time-consuming jobs or computationally most expensive jobs would be joins. So when you write a join, please make sure that the time constraints, if you're designing a web application with very low latency requirements, which means you're given a query and you have to respond, let's say in 1 millisecond, try to ensure that you don't have joins when you have to do that. Because when you have joins, it will take a lot of time, especially if your tables are very large. If your tables are large, it will take time to load these tables, join the data, and provide it to the final, to the software engineer to display it on a web app or a mobile app. Right? So joins can take time. So that's a practical note that you have to keep in mind.